Hi, my name's Matt Kline. I am currently a third-year PhD candidate here in the chemical engineering department. I work with Dr. Wheeler and Dr. Schwartz. I did my undergraduate degree in chemistry, and now I'm here doing my PhD in chemical engineering. So I chose the University of Maine after coming here for undergraduate work. So I was in an REU program, or Research Experiences for Undergraduates. And so I performed research over here during the summer, and I liked it so much that I decided to come back here. One of the things that I love about Maine is how it's so outdoorsy. So literally I get to walk or bike to work every day just through the forest. Plus we are an hour away from the ocean, and we're also an hour away from the mountains, and you can even the university here is actually on an island in the middle of a river, so it's literally, you have everything that you could want to do for outdoor activities here. So the research that I work on is actually on the ring opening of decalin and other bicyclic molecules. So if you know what cyclohexane is, it's one 6-membered ring. So I actually work with decalin, which is 2 C6 rings that are fused together. And I work on selectively ring opening those to produce molecules that are actually great for diesel fuel. So my research, in a sense, is actually taking some biomass-like material. We go through a process known as thermal deoxygenation, and I can take that fuel and use these catalysts that I've developed to efficiently be able to convert those chemicals into diesel fuel. This is my reactor, an example of my reactor setup. So my reactor is actually in here inside this insulation, and there's different reactor tubes that I use depending on the amount of catalyst that I need. So here's a smaller tube, and here's a thicker tube. Okay, so inside here is actually one of the reactor tubes, and they're placed in here. I'm currently running an experiment now, and it's currently at 750 psi and 300 degrees Celsius, so I would not dare touch it. But inside I have liquid and gas that flows into this reactor. We add hydrogen, the reaction occurs, and then I'm able to separate some of the liquids out from the bottom. After I separate the liquids from the bottom of my reactor and collect them, I go out and actually test them on an instrument known as a GCMS, a gas chromatograph mass spectrometer. And from there, I'm actually able to determine the exact molecules that are formed from this reaction. Then I go from there to try and optimize my catalysts to find the best ones to make diesel fuel. So currently, I'm working mostly with iridium and platinum-based catalysts over a variety of zeolites to try and find the best ones that'll give us the highest conversion and the best selectivities towards these desired molecules that we want that are great for diesel fuel. One of the great things about Maine is it's a lot more laid back than some of these other research institutes where it's like rah, 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 do your research all the time. Here it's more of a laid back attitude. Not to say that we don't do any work. I was going to say we work a bunch at a time, but you're allowed to go more at your own pace than some of the other research institutes, which require you to be on campus every day doing research and continuing doing your own thing. But I like Maine because it allows you to have more of a personal pace as opposed to some of the other schools.